Welcome back to First Take Math with Brian Thomas. Today we're going to continue to build on our lesson of exponents. We're going to do a couple of things. One is just calculating some expressions, and another thing we're going to kind of look at is simplifying some algebraic fractions. So let's start with this first example. We want to calculate negative 10 to the third power. So in this example we know that 3 means repeated multiplication. So this means negative 10 times negative 10 times negative 10. And then if we look at this, we can go 10 times 10 times 10. Well, 10 times 10 is 100, and 100 times 10 would be 1,000. Or if you want to kind of ignore that, you can go 1 times 1 times 1 is 1, and stick on 3 zeros. So get that 1,000 there. And then we learned that if you look at these negatives, one negative is negative, it flips to a positive, it flips back to a negative. So the answer is going to end up being a negative. Or as we said, an odd number of negatives, the answer will always be negative. This second example, we want to calculate this. This actually stands for the opposite of 2 squared. So if I look at this example, this actually means 1 negative 2 times 2. Notice how this negative is in parentheses, so this exponent had power over the negative. That means there's also 3 10s and 3 negatives. But here the 2 only has power over the 2. So there's only 2 2's and just 1 negative. So in this example we know that 2 times 2 is 4, and that just changes to a negative 4 because of just being 1 negative in the problem. So let's look at now simplifying some fractions. Again, to simplify fractions, we can use our prime factorization to focus on our numbers. So let's look at this 8 and this 12 to start with, and using our prime factorizations. And don't forget that 2, 5, 7, oops, put that 3 in there too. So 2, 3, 5, 7, and 11 are our first 5 prime numbers. And you know how the 2 works. See, it's pretty powerful. So 2 goes into 8 4 times. The 4 can be divided by 2. 2 goes into 4 twice. 2 goes into 2 1 time. So that's the factorization of our 8. The factorization of our 12 is, again, that 2 will work. 2 goes into 12 6 times. 2 goes into 6 3 times. 2 doesn't work for 3, but 3 goes into 3 1 time. So we can look at this problem now as 2 times 2 times 2 times x times x. Since that power 2 means there are 2 x's there. We also have 2 times 2 times 3 for the 12, and we have x times x times x times x times x. Since there's a 5 there, that means there's 5 x's connected together by multiplication. Now we can just start dividing things out. So we can see that these 2's will divide out, these 2's will divide out, these x's will divide out, those x's will divide out. So you can kind of see that our answer ends up being, there's a 2 left on the top, there's a 3 left on the bottom, and since there's 3 x's left on the bottom, we'll use exponents to represent that repeated multiplication. So that's going to be a 2 and then a 3x to the third on the bottom. So notice how again there's 2 2's or 2 x's on the top, there's 5 x's on the bottom, so we can literally take away 2 of the x's and we're left with 3 x's on the bottom. Our next example we have x to the 5th squared. So looking at the outside exponent, this tells me that there are 2 of these. So I have x to the 5th times x to the 5th. To simplify this, we know that this means 5 x's multiplied together, and this is 5 more x's multiplied together. So literally, this tells me that there are 10 x's multiplied together altogether, so I can use an exponent to express this in simplest form. So if I have a power to a power, we kind of change it to repeated multiplication, but this repeated multiplication actually turns into 10 x's and 5 more x's, a total of 5 x's and 5 more x's, it's a total of 10 x's. And that's our simplified answer. looking at this example again, we have numbers and letters. The numbers, a good idea is to use a prime factorization. So we've got this 25 and this 35. Well, the 2 doesn't go to 25, because remember, 25 is not a number. 3 does not go to 25 either. 5 does. 5 goes into 25 5 times, and 5 goes into itself 1 time. That tells me I'm finished. Again, that 5 works really well for that 35. 5 goes into 35 7 times, and a 7 will go into itself 1 time. So I can change this to then 5 times 5 times x squared. And on the bottom I have 5 times 7 times x times y. If I need to, we can change this to 5 times 5 times x over then 5 times 7 times x times y. And then we look for dividing out factors. So the 5's will divide out, a pair of x's will divide out, and then we just put it back together. So we have a 5 and x on top, so we just put that back together. That's 5 times x. And remember, 5x together means multiplication. So we have a 7 and a y, so we can write that as 7 times y, or just simply 7y. And that would be the simplified form of that expression. So you kind of see that these both have a 5 you can take out, which leaves you a 5 and a 7. Notice how there's 2 x's here and 1 x there, so I can mark out an x. We're left with an x on the top and just a y on the bottom there. So you almost can do that polynomially if you think about it. So hopefully that will be helpful into moving you into some simplifying fractions in this type of form.